So in this unit, we're going to be looking at congruent angles. Last one was complementary, supplementary, where they add to 90 or add to 180. This one, we're talking about congruent. Congruent means equal. So angles that have the same measures, they're the exact same size. So by the end of the class, you'll be able to prove and apply vertical angles are congruent. That's a huge, huge concept that we're going to use. Vertical angles, you'll probably use it at least 100 times this class. Along with alternate interior and corresponding angles when the lines are parallel. These are building blocks. You're going to use it, like I said, hundreds of times. Almost every single proof that we're going to be getting to is going to use either vertical angles or alternate interior angles. Almost every single one. And when you write a two-column proof, if you can use these concepts in your two-column proof, that means you got it. Or a flow proof or a paragraph proof, whatever. So vertical angles. Vertical angles makes an X. That's kind of a quick way to look at it. Whenever you see an X between two lines, make an X, you've got vertical angles. So here's two lines that make an X. So that means we've got vertical angles there. So to talk about all these angles, I'm going to number them. Because the vertical angles are the angles that are opposite each other after the lines intersect. So they're the ones that are across from each other, like the top of the X and the bottom of the X, or the left and the right of the X. So angle 1 and angle 2, no, not angle 2, angle 1 and angle 3 are vertical angles. And then angle 2 and across from it, that'd be angle 4. Those are vertical angles. When they are across from each other, that's vertical angles. That's vertical angles. When they are across from each other. So we're going to look through a proof that's going to use vertical angles a little bit. So every time you do a proof, the very first thing you're going to write down is the given. So here we are given angle 1 and angle 3 are vertical angles. That's going to be our very first statement. You always start at the beginning. You always start with the given. Then you can look for anything else that you know from that picture. Anything else that you know. So from this picture, we know a couple of things, actually. We know that angle 1 and angle 2 are a linear pair. We know that angle 3 and angle 4 are a linear pair. We know that 2 and 3 are a linear pair. And we know that 1 and 4 are a linear pair. We have all those linear pairs. And we also know that 2 and 4 are vertical angles, yes. So, like I said though, 1 and 2 are a linear pair, which means they're supplementary. Also, 2 and 3 are a linear pair, which means they're supplementary. So we kind of join two statements with the same reason. So the art of the proof is you have to know what you're starting with and what you're trying to get to. Proof talks about wanting us to get angle 1 and angle 3. That's why we made sure that we chose angle 1 and angle 3 in our linear pairs that we chose. and then we wanted something in common between them so that we can link them together. So angle 2 was what was common between them so we could link them. So supplementary, like we wrote, means that they add to equal 180. So now we can turn it into an equation a little bit. Remember, our reasons can always be theorems, definitions, postulates, given. All of those things are things that we use for reasons. So the definition of supplementary angles gives us an equation now. Now that we've got equations, we can do algebra. That's where we're going to be going from here. Since they both equal 180, we can set them equal to each other. Angle 1 plus angle 2 equals 180, and angle 2 plus angle 3 was 180, which means they're equal to each other. A substitution, that's actually also the transitive property. Substitution's fine here. So now it's shaping up a little bit more like something that you could do in algebra. We've got one equation now instead of two equations. And in fact, we've got the same thing on both sides of the equation. We have measure of angle 2 on the left side. We have measure of angle 2 on the right side, which means we can subtract that from both sides using the subtraction property of equality. You subtract it from both sides, it's gone, and you have angle 1 equals angle 3 right there. Measure of angle 1 equals measure of angle 3. So we just said that the angles were equal. We're trying to finish our proof by saying that they are congruent. Congruent just means they have all the same size and same shape. So for angles, that means that they have to have the same measure, which they do. That's what it means to be congruent. So we said to change our equals to a congruent. Definition of congruent. So what we actually just proved is this statement right here. If two angles are vertical angles, then they are congruent. If two angles are vertical angles, then they are congruent. So angle 1 and angle 3 are vertical angles, which means angle 1 is congruent to angle 3 because they are vertical angles. Angle 2 and angle 4 are vertical angles, which means angle 2 is congruent to angle 4 because they are vertical angles. Now, we just did a proof for it, so we know it's true, but it's also pretty easy to know that it's true because you can take these two lines. Let me trace over them real quick. And you can rotate it. And I rotated it 180. I'll rotate it back 180. Whoops, too far. And you can see that angle 1 and angle 3, when you rotate it around, that they match up. So you can kind of see that they are congruent because of a 180-degree rotation. You could also know that instead of rotating, if you drew a line right about there, you could also reflect it over, and you could see that they're congruent by reflection. You could fold that in half and see that they're congruent by reflection. So an easy way to identify that vertical angles are congruent is either by rotation or a reflection. Rotations and reflections show that vertical angles are congruent also. or reflection. Rotations or reflections show that vertical angles are congruent. So a lot of times what we're going to do is you can figure out a lot of angles based off of maybe just one and a kind of crazy picture like this. So we know, because it's written right here, angle BYE and IYL are each 20 degrees. They're each 20 degrees. All right, so we fill in those angles that you know. BYE, trace it out, that's 20. IYL, that's also 20. So there's a lot to this that we know. We're trying to find all the missing angles. So we can use vertical angles, we can use lots of stuff. But what we're going to start with is we know that this is 90 because it's marked. And we know that that line right there is a straight line, which means that's 180 degrees total. All this way is 180. So that means that 90 degrees plus 20 degrees plus whatever this is has to equal 180. So 90 plus 20 is 110, which means that X, it's got to be whatever is going to make 180. So that angle right there is going to be 70. Then we've got some vertical angles. If you take a highlighter, you can see vertical angles. You connect that line and that line. We've got vertical angles right here. Angles that are across from each other. So if this is 70, across from it is also 70. So it's not quite vertical angles here because these are not straight lines. Each one of them is bent. We can't do vertical angles, but we can look back at that same first line that we drew, that straight line. And we know that 70 plus X plus 20 is going to be a straight line again, 180. So 70 plus 20 plus X is a straight line, that's 180, so that means X equals 90. Now we got all the angles.